Hi! Welcome back to the third portion of our video tutorials. We will be discussing on how to solve problems related to volume of distribution. So, fasten your seatbelt and let's begin. Problem number 1. Plasma drug concentration immediately after administration of a 30 mg intravenous bolus dose was found to be 0.32 microgram per ml. Calculate the volume of distribution of the drug. For this problem, we will be using the formula volume of distribution is equivalent to dose divided by plasma concentration. So let's look at the given. The 30 mg here is the dose, and the 0.32 microgram per ml is the plasma concentration. Now, since the two are not in the same unit, so we have to convert the plasma concentration into milligram by multiplying with 1 milligram divided by 1000 microgram. So, 0.32 microgram per ml becomes 0.00032 milligrams per ml. Then let's substitute. Dose is equivalent to 30 milligram divided by the plasma concentration, which is 0.00032 milligram per ml. So we'll be canceling both the milligram, so we're left with ml. So 30 divided by 0.00032 is equivalent to 93,750 ml. Now, we have to remember that the volume of distribution must be in liters. So, we will convert this 93,750 ml into liters. So, now our volume of distribution is equivalent to 93.75 liters. Problem number 2. The apparent volume of distribution of a drug is reported to be 2 liters per kilogram body weight, and it is desired that concentration of drug immediately after intravenous bolus injection should be 2 milligrams per liter. If the patient weighs 75 kilogram, calculate the size of dose that should be administered. For this problem, we are looking for the dose. So, with this formula, VD is equivalent to dose divided by CP. So, let us derive the dose. So, the dose now is equivalent to VD times plasma concentration. From the problem, we have 2 liters per kilogram body weight. That is the volume of distribution. So, since per kilogram, so we have to know how much the patient weighs. So, the patient weighs 75 kilogram. So, to get the total volume of distribution of the drug, we have to multiply the 2 liters per kilogram with the weight of the patient. So, 2 liters per kilogram times 75 kilogram is equivalent to 150 liters. So, this is now the volume of the distribution of the drug. And then, the 2 milligram per liter is the plasma concentration. So, let us now substitute. Volume of distribution is 150 liters times the plasma concentration of 2 milligrams per liter. So, we will cancel both liters and liters. So, multiplying 150 with 2 milligram, so we have a dose of equivalent to 300 milligram. Problem number 3. A 200 milligram dose of a drug was given by rapid IV injection, and this drug is known to bind to plasma proteins. If the drug distributes instantaneously in total body fluids and the drug is 40% bound to proteins, calculate the concentration of unbound drug in plasma after administration of the dose. In this problem, we are looking for the concentration of the unbound drug. So, let us try to analyze the problem. The 200 milligram here is the dose. But it is mentioned that the drug is 40% bound to proteins. And we are asked of the unbound drug. So 40% bound, that would mean that only 60% is the unbound portion of the drug. So 60% of the total dose, which is 200 milligram, is equivalent to the 120 milligram. So, anong ibig sabihin nito? This 120 milligram is the unbound drug. And this is the part of the drug that we are looking for the plasma concentration. So that is the first given, the dose. How about volume of distribution? So walang ibang binigay ang problem except that merong nakalagay total body fluids. So we have to take this into consideration. If you remember in the notes I gave you, the total body fluids of the body is equivalent to 42 liters. Since sinabi ng problem that the drug distributes instantaneously in total body fluids, so we have to take it that the volume of distribution of this drug is equivalent to the total body fluid, which is 42 liters. So these are the given. Now let's go to the formula. So this is the original formula for volume of distribution. And if we are going to extract the formula for plasma concentration, so Cp now is equivalent to the dose divided by the Vd. So the dose that we will be using is only the 120 because it is only the unbound portion of the drug. So 120 milligram divided by the volume of distribution, which is 42 liters. This is coming from the total body fluids. So we have now a plasma concentration of 2.86 milligram per ml. So ibig sabihin nito na yung unbound portion ng drug, ang plasma concentration lang niya is 2.86 milligram per ml. Problem number 4. Following administration of a 250 milligram IV bolus dose of a drug, the plasma concentration of drug immediately after injection was found to be 17 microgram per ml. Calculate the apparent volume of distribution. For this problem, we are looking for the volume of distribution. And this is the formula. Vd is equivalent to dose divided by Cp. So let us try to know the given. 250 milligram is the dose, while the 17 microgram per ml is the plasma concentration. Since they do not have the same unit, so we are going to convert the plasma concentration into milligrams per liter. So 17 microgram per ml times 1 milligram over 1,000 microgram, since there are 1,000 microgram per milligram. Then multiply again with 1,000 ml per liter. By doing this, we can cancel the microgram, and the ml. So we will be left with milligrams per liter. So 17 times 1,000 divided by 1,000, so is equivalent to 17 pa rin. So our Cp now is 17 milligrams per liter. So let us substitute. The dose is 250 milligram divided by the Cp, which is 17 milligrams per liter. So we will have a volume of distribution equivalent to 14.7 liters. Problem number 5. A patient received a 300 milligram dose of an antibiotic by IV bolus injection at 6 a.m. At 10 a.m., the concentration of drug in the body was 2.4 micrograms per ml. If the apparent volume of distribution of this drug is known to be 37 liters, calculate the amount of drug in the body. For this problem, we are asked to calculate the amount of drug in the body at 10 a.m. So amount of drug, so we are looking for the dose. So this is the formula for the dose. Dose is equivalent to Vd times Cp. So let us try to know the given. 300 milligram is the dose. So this was given at 6 a.m. But at 10 a.m., a plasma concentration was measured, which was equivalent to 2.4 microgram per ml. Then another given was the volume of distribution, which is 37 liters. But the question is, calculate the dose at 10 a.m. So these are our given. Now, our Cp is in microgram per ml, and our dose is in milligram. So again, we are going to convert this one into milligrams per liter. So 2.4 micrograms per ml converted into milligrams per liter becomes 2.4 milligrams per liter. So this is the solution. Let us try to substitute. VD is 37 liters times the CP of 2.4 milligrams per liter. So the dose of the drug is 88.8 milligram. So ibig sabihin, at 10 a.m., this was the dose that gave the plasma concentration of 2.4 micrograms per ml. Now, let us try to recall the formulas we use for volume of distribution. Now, this is the only formula, no? VD is equivalent to dose divided by the plasma concentration. But from this formula, we can extract or we can derive the formula for dose and CP. So dose now is equivalent to VD times plasma concentration. And plasma concentration is equivalent to the dose divided by VD. So the only thing that you have to remember is that the volume of distribution must always be in liters. And when trying to solve problems, you have to have the same units so that your answer will be correct.